Hello, this question is asking us to list the data in order from least to greatest standard deviations. And we have three different data sets, A, B, C. So standard deviation, as I have in my notes down here at the bottom, is talking about the spread of the data. So it's a measure of spread. The larger the standard deviation, the more spread out it is. We have a couple different graphs here, and you can see how this first one is very clumped together between 18 and 19. So it's got a very small standard deviation, whereas graph B has a very wide range, from 18 to 100, so it's very spread out. So that is going to have a larger standard deviation. So when we're given three different data sets, we're asked to go from least to greatest in the standard deviation. Really, we're trying to figure out which is the most spread out, which is the least spread out, and then which one would be in between. Now, when I look at these data sets, we note that they are not in numerical order, so that adds a little challenge. I mean, not a lot, but you can't just look at the numbers. You have to think a little harder. And so, but what I do notice is that data C has a lower value of 74. That's the minimum of all of them, but it also has a maximum of 110. Whereas the other ones, max data A and B, I just have maxes of 100. So that tells me that this C is the most spread out, going from 74 to 100. So I can pretty confidently say right now that data C is going to be the most spread. So I'm going to put a C here. Excuse the calculator work here as my hand is hitting it. But so now we have to figure out between A and B, and notice that they have some similarities, 75 to 100. But you see these are a lot of 88s. We have 88s and 70s and 97s. So you can kind of guess as to which one is going to be the least spread out, or we can use our calculator to help us calculate the actual standard deviation. So the surefire way to not be not even guessing at all or even thinking all that hard, you could just use your calculator. And so if you use your 1-var stats, you can see that we have the SX is the sample standard deviation, the sigma X is the population standard deviation. So that's just if this data is from a sample or a population. This doesn't have any context, so we don't know. So if you go into your stat list, I've already got these data sets entered in here to speed up the video, but I have them entered in three different data sets, so L1, L2, L3. If you were doing this on your calculator, you could do it all in one. You could just find one standard deviation and then delete it, and then delete L1 and continue. But just so we can see, we're going to look at these. And so actually what we can also do is we can sort these lists for oops, I didn't want to do that. Let's see what I did here. Okay, so we could also go and we could sort these lists if we wanted to see how clumped up they are, but let's just start with the 1-var stats. So I go to Calc, 1-var stats, and I'm going to do list 1. That's exactly what I want. So I hit enter, and my standard deviation is 7.78. Population is 38. We don't really know which one is which, so we're just going to list that for data set A, the standard deviation. We'll use the population because we don't know whether it's a sample or not. So we'll say this is 7.38. So that's the measure of spread. That's how spread out it is. And then we can do that for data set C as well. So if I go to stat, and then I'm going to calculate my 1-var stats, but this time I'm going to go up and I'm going to delete this and say I want it for L2. And then I hit enter, and my standard deviation is for population is 5.62. Okay, so that's much smaller. Standard deviation is equal to 5.62. And then just for the sake of argument, we'll go ahead and do data set C, and so which is in L1. So if I go up to here and I delete this out, sorry, this calculator doesn't cooperate as much as easy as one that's by hand. So if I delete this out and I go to L3 and I hit enter, we see that it is 9.59, which is in fact the largest. Standard deviation equals 9.59. That's what we thought, because this is going from 74 to 100. And we see that we have 75s. All this data is right around the 80s, 87 to 89 really, except for the 100 and the 75. So that's a lot of clumping around the 88. Here you have 88, 77, 97. So you have these numbers out here really change that standard deviation. Even though those don't look all that different, having that 76 and 97 in there change that standard deviation for data set A. So from least to greatest, it'd be B, and then A, and then C. And so that's how you calculate standard deviation and what standard deviation